define Q by pi R square. I assumed an elemental ring because they charged object, no? So we should assume an elemental ring. So there's an elemental ring. Let the radius of this small r, let me take this one. And the thickness of this be dr, the charge on this be dq. Now what is this elemental ring? Okay, already we have discussed this in the electric field. No? So at point P, we have to find out the field. So there's a, what is the dq will define? First, potential at point P on the axis. So this. Call this is R. Okay, now write the expression for this. dV is equal to K dq by R. Potential at point P, first due to elemental ring. So further, what is K? Sigma into area of that. R, oh, this is, I'll put it Y. So this should be equal to how much? Y square plus X square. This will be, I'll change proportion of this symbol. What is dA? Area of the strip, circular strip. So dA should be equal to 2 pi y dy. Y square, X square. So this will be 2 pi K sigma, 2 pi K sigma y dy root of y square plus X square. So can we integrate this? I think there's a big problem, no? These are unknown. Y and X both are variable. So let me take the mathematics. So from the mathematics, tan theta equal to y by x. So y equal to x tan theta. I'll differentiate this. dy equal to x secant square theta d theta. Let me substitute all
Sir,
this.
in that equation, x is not variable, no, sir, because we are considering at one point.
Oh, okay, fine. You mean to say this x? X is a fixed one, no?
Yes, sir. You said x variable, that is why I was telling, sir.
Okay, okay, sorry. I'll take it back my word. So x is okay, fixed point here. Here what will happen as for there's a one thing, no, y will be variable. So how to integrate? I'll just go for substitution type here. So dy is equal to, substituting this will be dv equal to 2 pi k sigma y is x tan theta dy y square x square tan square theta plus x square 2 pi k sigma. X will get eliminated. Keep tan theta. 1 plus tan square theta secant square theta. I'll get secant theta. And dy is what? Dy value also substitute. No? X secant square theta d theta. Secant theta. So 2 pi k sigma x secant theta tan theta d theta. Check the calculation once, simplification part, then I'll proceed. Okay, till here? Now what is sigma? We'll substitute the sigma value. I'll scroll down. So this is dV 2 pi sigma is what? Okay, let it be k is what? 1 by 4 pi epsilon naught. 4 pi epsilon naught sigma x I'll take outside. So secant theta tan theta d theta. Integral of secant theta tan theta d theta will be secant theta. So 2 pi sigma x 4. Okay, this will be sigma x by 2 epsilon naught secant theta. So the limit, let me write here only 0 to capital R. You can change in terms of theta. Let it make very simple. So now replace this with sigma x by 2 epsilon naught 1 by cos theta. Now what is cos theta from the diagram? Sigma x by 2 pi epsilon naught cos theta will be x by root of y square one x will get cancelled out 2 epsilon naught. This will be r square plus x square minus r. There's a one formula which you have to remember, very important for us.
Minus x, sir.
Y will be 0, no? Yeah, minus x. This, I think nobody will ask you in exam, the derivation, but the formula plays very important role. You check the, especially exams, no? Student know this formula, you can enter into the question, or else you have to derive. This much of derivation not possible. Exam timings will not permit you. So therefore I suggest you, like by this time, almost by today, we'll finish off all maximum charged objects, the field and potential in hand. You must be ready. So there's the expression for the potential due to charged disk on its axis here. Now you do have some application with mechanics also. There'll be some point charge, given velocity, some numericals are there in the book, no? Just focus on them also. So I got this electric potential due to uniformly thin charged disk. I put R like a R equal to infinity for very large sheet. What will happen? See, just analyze once. For a large sheet, we know. For a large sheet, we know something like this. No, for a large sheet. What is the electric field? Sigma by 2 epsilon naught. What about potential? Put R equal to infinity. Will be infinity. Huh? That's why for large objects, like if the charge is distributed, the reason for that, at infinity also the charge is present. Due to that, there will be potential non-zero. So therefore, when charge is distributed till infinity, what happens? We can't define the potential at infinity. You see that will end up like this. Say mathematically, I'm writing it. What does it mean? Better don't define there. So then how to define point at anywhere near the charge sheet? We'll take help of first we know electric field, then dV equal to E into dr, I'll use that formula, I'll get the potential.
Sigma equal to Q by pi r square. Again, in the denominator, we will get r square.
No, sigma is a fixed value, no? Don't use mathematics here. Sigma is a value for a given charge sheet, it's over. Last charge sheet, sigma is a value. Sigma is some value. Again, why you are substituting that? There'll be uniform value. Sigma will be fixed for a charge sheet. Don't bring mathematics here. Sigmas are q by pi r square, 1 r also infinity, infinity by infinity. Not like that. Sigma is the one value. Uniform charge distribution. Charge per unit area. It will be a fixed value. Okay, this, so I'll come to later part this. Just have an idea that. So there's a one method. So this formula is very important. That's what I feel. Okay, let's take some application of this. How the questions can be asked for you. So now you know some information on this. If you know this, can you find out the field? If you know potential, can you find out the field? Differentiating, no? dV by dx, you differentiate, you'll get expression for the electric field what we derived. So there's one advantage. For a charge body, you find out the potential, differentiate, then you'll get the field. Like what we did for point charge, you can do for disk also here. You differentiate this, you'll get electric field strength on the axis. Instead of the derivation, you can directly end up from here.